Hello everyone. Good afternoon. Good evening. Can you hear me well? Can you please confirm if you can hear me well and see my screen in the questions window, please? Thank you, Kunal. Thanks, Abhishek. So looks like my connection is working. Thanks, Madan, again for confirming. And let's maybe wait a couple of minutes to let everybody get a chance to join, and we will start this discussion in maybe 2 minutes. Yeah. Thank you. All right. So thank you for waiting. Let's begin the today's session. I hope everyone who is interested to join has joined by now. So welcome to today's webinar. Today's webinar is arranged by Edureka to discuss more on the Docker files. Right? I am hoping that you guys are already aware of Docker. You guys know what is Docker, what is containerization, what are containers, what are the advantages and disadvantages of using containers, uh, and what are images, how do you generate containers out of images, how do you share your images with your counterparts, maybe your peers, your customers, or anyone else. So today we are going to understand more on what is Dockerfile and how do you create Docker images using Dockerfile, right? So we will briefly look into what is Docker, and then understand the Dockerfile, understand the Dockerfile syntax, various commands that we use in Dockerfile, and then for demonstration, we will create two Docker images, one based on Apache and one based on Nginx, right? And then we will deploy them and see if we were successful and what all things we did to create those images, and maybe ask more questions. Yeah. So question and answers will be continuous throughout the webinar. Whenever you feel like asking me a question, please drop a message on the questions window. I may try to answer it immediately, or I may hold on the answer for some time if I am in the middle of an explanation. Once the explanation is done, I'll pick up the question back and try to answer you. Yeah. Before we begin, just a small information about myself. My name is Amit. I'm based out of Bangalore in India. I have been in the industry for around 15 years now. I started my work as a developer on C and C++. Did my development for quite some time now, did a little bit of verification as well, and then moved into build and release, and then release management, and then DevOps role. So right now I work as a DevOps manager in my current organization. I manage a team of 4 people, and we try to identify any problems on DevOps side for our R&D teams and deploy solutions for them, and also maintain the solutions. So we here in my current role, I try to deliver DevOps solutions to my internal and sometimes external customers as well. Yeah. So let's start. Let's understand what is Docker. A brief understanding. I'm sure you guys are already aware of it, but just to bring things in context. So context, I'll just make a full screen here. So Docker is the new way to deploy applications, right? The oldest way was to have a monolithic system, maybe a big server, a Windows server or a Linux server, running on a very powerful machine, maybe a 16 core, 48 gigs RAM machine, things like that. And then you deploy all your applications on that machine, right? So if you want to run, let's say, an HTTP server, then you deploy the HTTP server on that machine. If you want to run a Git server, then you run Git server on that machine. If you want to run um, I don't know, a Jenkins server, then you run the Jenkins server on that machine. So on one machine, on one platform, we used to run multiple application. Now each application may have its own platform requirements, right? Maybe Jenkins needs Java to be available on the system. Git needs certain libraries, C libraries to be available on the system. HTTP needs certain binaries and libraries to be made available on the system, right? So we have to make the libraries available, and which become common libraries for all the applications. So on the left hand side, when you see the old way to deploy the applications, you can see we have a common kernel, which is a common operating system. And then we have libraries, which are again commonly available for all the applications. And then on top of that, we run individual apps, right? But this was the old way. How do you, I mean, what has changed? Why do we have a new way? Well, in new way, we make our applications more portable, right? In this case, in the first case, we had an application and we need to specifically provide the dependent libraries for the application on the system, right? So if we want to install Jenkins on a system, we need to make sure by ourselves that certain version of Jenkins is already installed on that system. Sorry, certain version of Java is already installed on the system. So Java is a dependency for Jenkins, right? So any machine you want to run Jenkins, you need to install Java. But then that is a dependency, and that dependency has to be resolved by the person who is installing the application, right? What if we want to remove the dependency? What if we deliver Jenkins along with the Java and all the requirements that are required by Jenkins, so that our deliverable is a complete package which has all the things required to run our application? So for this solution, containers came into picture. Using containers, we can bundle our application. So in our example, Jenkins, along with all the dependencies. So your operating system utilities and your Java, you bundle all these things together, create a Docker image and give it to our customer. So instead of giving the Jenkins installer, we give a Docker image which has Jenkins and all the dependencies already packed in. So we give this to a customer and request the customers to run a container out of it. Running a container is very easy. You say Docker run and give the image name and it'll run the container. So a container is a self-sufficient application environment, right? You say Docker run Jenkins and it will run Jenkins. You don't need to worry about installing Java on your system or installing any other dependencies on a system by yourself, because everything is packed inside the container already. So all you need to provide is a kernel, which is an operating system, and a layer of container engine like Docker engine or maybe Rocket Ship or any other container vendors. And then on top of that, you can run your images. Yeah. So this is what was the use case for Docker, right? How do we use Docker when we use it in our daily life? Uh, to use an application, in our case, a Jenkins application, to use that, I need to get the Jenkins image in my local machine where I want to run a container, right? To get the Jenkins image, I need to download the image from somewhere, right? Maybe my friend has it, or maybe the Jenkins vendor has it, or maybe my company provides me the image, but I need a source. So generally, the source or the location from where you download the images is called a Docker registry. The most popular Docker registry is Docker Hub. Docker Hub is a registry provided by Docker themselves, where you can store your images and then download the images, run on your systems, and run the applications. Right? So now the next question is, who puts the images on Docker Hub? Huh? Somebody creates an image and puts the images on Docker Hub, right? And that somebody can be your vendor, maybe CloudBees, which is a company which develops Jenkins. So maybe that company creates Jenkins images, or some other person can create Jenkins images based on their adaptations, their variations, their customizations, and create an image and put it on Docker Hub, right? And then allows us to download that image and use it in our environment. Now, how do they create an image? That is the concept that we are going to learn today. How do we create Docker images, right? Any questions till now? I see everyone is silent. There are no questions. So I'll encourage you guys to ask me questions. Question from Karthik. What if my lower environment does not have internet access to Docker Hub during deployment? In that case, you can have your own private registries, right? You do not need to be dependent on Docker Hub. You can run your own registry. You can develop your own registry, right? So maybe if you are working for, let's say, a company called IBM, right? Not that I'm associated with IBM, just taking an example here. If you're working in IBM, inside IBM data center, you can have your own registry. You can push all your internal images to that registry, and your internal Docker cluster, or Kubernetes cluster, or any Docker environment that you use, can pull the images from your internal registry. No need to talk to Docker Hub. Question: what is the image between Docker image? What is the difference between Docker image and Docker container? All right, then we will go to next sections. Let me find out my right. So what is the difference between Docker image and Docker container? A container is a process which is created from an image, right? Uh, it's like an exe. So image is like an exe. You get an exe, but it's just sitting there on your system. To use the exe, you have to execute the exe, execute the binary. When you execute the binary, you get a process, right? When you want to watch a movie, you download the movie file, but it just sits there on your system. Unless you execute the file, you do not get to see what is inside it. So similarly, an image is a static data which contains complete information about your application, but it is again static data. It is just flat files sitting in your system, occupying space on your hard disk. Once you run a process out of that image, then it becomes a container. A container is a running process created from a particular image. Yeah, maybe I will show you a small demonstration. So this is my Linux machine, right? Okay. Can you guys see my screen properly? Is the text visible to everyone? All right. So let's say I want to run Jenkins. Yeah, I would say Docker run Jenkins. Now what I'm saying here is I have this machine here, which is called instance 4. Yeah, and I'm running a Docker container. I want to start a Docker container. So I give the command Docker run. Run means start a container, and container based on Jenkins image. Yeah, I will also give some arguments just in case. Let's not talk about these arguments, but I'll just give them in case. Um, yeah, so I say Docker run a container based on Jenkins. Yeah, you can use any other application. Praveen, it is just an example. Yeah, you can run HTTPD, you can run Tomcat, you can run any application which you want. What we run is not of value for us. How we are running it and what happens is the value for us, right? So I say Docker run Jenkins, and it starts a container for me. The image was already present in my system because I already downloaded it from from Docker Hub. We can remove the image and see ourselves if we want. Maybe I will do that. Okay, auto completion is not available. It is fine. So I'll delete this container and I will say Docker. I will remove the image which is already downloaded. Yeah, let's ignore all this. Let's start fresh. Let's say I want to run a Jenkins application. First thing is I want to pull the image. So I will say Docker pull Jenkins, right? I'm assuming that you all guys already know this, right? Because this discussion is only on how to create images, right? So that means you should already know images. But again, I'm just giving some reference. We will not go into much deeper into Docker basic concepts. What is an image? What is container? What is Docker? Because if we do that, then we will not learn Docker files today. Yeah, because we just have 1 hour, 10 minutes with us. Okay, so Docker pull Jenkins, press enter, and it downloads an image for me. What is everything here? Why so many downloads? Let's not get into that. We don't have enough time and bandwidth to do this. But for now, it is downloading the image for us. So I will wait for the download to finish. And now we have Docker Jenkins image with us. Now I say Docker run and give some arguments to expose some ports and say Docker run Jenkins. Press enter, right? My container is running. I can see that my container is running. My container is running and I should be able to see the application on port 8080, right? The output that we get after running this command is the ID of the container. Okay, now let me connect to this application on IP address and port 8080. Let's see what do we get. And I get my Jenkins here, right? This is the initial page of Jenkins. This is my Jenkins, right? Now, if I stop this container, I say Docker stop and the container name, done. Now the container has stopped. That means my Jenkins application should have stopped. If I reload this page, should not get anything. There is nothing here. Yeah. All right. So this is how we run a container. Now the discussion that we are going to have today is how do we create these images? If I want to create an image of my own to give to a customer or to a client, how do I create this? Right. So that is our core discussion topic today. Right. So this specifies what we did. We pull Docker images as a user of Docker images. We pull Docker images, pull from Docker repository, right, and a registry, and then run containers out of it. Yeah. Just give me a moment. Yeah. So now, how do we create our own image? So to create our own image, we don't need much. We just need a machine where Docker is installed, and we can create our own image, right? So to create our image, we need to have access to a base image, right? Base image is an existing image which we are going to customize for ourselves. Essentially, when you create an image, you customize an existing image for your application. So basically, we use an existing operating system level image, right? There are images, Docker images available for Ubuntu, Docker images available for CentOS, Docker images available for Red Hat, Core OS, Scientific OS, almost all operating systems except Windows. So there are images available for, and Mac. So there are images available for Linux based operating systems, which one of those we use, and then we create our own images. Yeah. So Praveen, I think you have a good point here. Base image is an image which has no programs installed. Exactly. So base image is a basic vanilla operating system image, which has basic operating system utilities present in them. That is all. I hope that makes sense. Yeah. And then we add on top of the base image, vanilla image, we add our own customizations. So we choose a base image, right? And we add some metadata. So that means we define some information about our image, like who's the maintainer, who's the vendor, and all that stuff. We can add some files using add commands. Yeah, we can define what are the parameters that we pass to our container when a container runs. If any parameters can be passed using cmd command, the command that is executed by default when we run a container out of our image as entry point. If you want to set up any environment variables, then we will use env. If we want our application to be accessible on certain ports, like for example Jenkins is available on port 8080, then we will expose those ports. If you want to run our program or our application in the container as a specific user, then we specify that. Any volumes that we want to use, which means any file or folder with our image, and any current working directory which we want to define, right? So we will use all this. Maybe it does not make sense to you right now, but we will use all this to create our own image, right? So what I will do is I will write a Docker file, right? I will start with a very small Docker file and then explain all the commands. So a Docker file is just a very simple file. It's a very simple file. It does not follow any strict programming syntax. We can either write comments in the file with the hash, starting with a hash, or we can write some docker file specific commands. Okay, so let's write this very small Docker file, and then we will see what we did, and I will explain more on what we are doing. Okay, so I will say nano is my editor. I will say nano Docker file. I will create an empty Docker file here, and I will say this is a comment. This is my first Docker file. Yeah, and I will say from use Ubuntu 18.04 image, right? And I say cmd. Yeah, I will give this. So this will mean what this means. This means is we want to create a new image. Yeah, and in the new image, we want to make it make use of an existing base image, which is Ubuntu 18.04 version. And then we want to run this command. We want to set this command as default in our new image. So whenever I run a container out of this image, this command should execute, right? There's a question, can we use any other name apart from Dockerfile? You can use any name. The name does not matter. By default, Docker build command looks for Dockerfile, but you can use any name. Yeah, so I will save this. I will save this file, and now I will say Docker build and I can specify which Docker file I want to build, right? Docker build, and where is my file located, or where is all the data required for my new images are located, right? So I need to give dot. Okay, dot is means current, in the current location all my data is located, right? I also want to give the name of the image that will be created. So I need to give a tag. So -t, my Docker image is the name of the image that I want to create. So my input is Dockerfile. My output is this image, right? It may be a bit wrong here, so I will put this at end. Now I can run this command, or I can remove this -f Dockerfile also, because by default, if you don't provide a file name, Docker looks for Dockerfile with the capital D uh, to be built. So this is the default file name Docker looks for. Yeah, so I will run it like this, let's say. So now Docker is building something. It has finished completely, it has finished the build. So it says step one, there are two instructions provided in the Docker file, if you remember, a from instruction and a cmd instruction. Step one, from Ubuntu. So it will, my Docker will now make the Ubuntu 18.04 image available in my local system so that it can be used to create my new image. So it will pull down this image, right? And then step two. Step two is set this default command. So when I run a container out of my new image, which is my Docker image, it should print hello Edureka by default. So if I say Docker run my Docker image, yeah, press enter, it printed hello Edureka and finished. You can see, printed hello Edureka and finished. So this was my small application which prints hello Edureka. That is all. Correct. So how did I achieve this? I used a cmd command in Dockerfile, which we will take a look what each command is. So now I created a new image, which is my Docker image, which is based off Ubuntu and does some custom tasks, which I defined here. The container is terminated. The container is terminated because I did not ask the container to run in background. Okay, so the container did its job and terminated. So this is how we create new images. So once we have a Docker file, we use the command docker build to build an image out of the Docker file. Yeah, I can scroll down, but there is nothing there. There is nothing here. I'm at the end of the terminal. Are you having difficulty in accessing the bottom of the screen? So Nikhil, let me know if you have any problems with bottom of the screen, because all my commands will be coming here. Okay. All right. So now what are the commands we can use in Dockerfile? So Dockerfile can have two kinds of lines or text lines. One is a comment which starts with a hash sign, right? And then you have some command and then argument for that command. Okay, so what are the various commands that we can have? First command is add. Yeah, add means if you want to add some of your own data to to your new image. In that case, we use add, right? So let's take an example here. Maybe I will modify our Docker file in the runtime. I will say nano Docker file, and here I will say, let's say I want to add um, sample.txt. I create a file called sample.txt. I add it, and my command I will change to cat and sample.txt. I will add the sample.txt to root and print it from here. So what I'm going to do here, I'm going to create my image. I'm creating a new image uh, based on 18.04 Ubuntu, and uh, I run a command in the Docker file. I give a command called add. That means I'm instructing Docker to build a new image from Ubuntu 18.04 and take this sample.txt from my current location and put it at this location in the image. Yeah, and then I will run this command. Command is cat command. I want to execute a cat command to print out the contents of this file. Okay, so I will do that now. Save, and I need a sample.txt as well, so I will create a sample.txt, and I will say hello, this text comes from sample.txt, right? So now, okay, if you're facing problems in accessing bottom of the screen, then maybe, is this better? Can you see the screen better now? Maybe I'll do this much. All right, so now I have my sample.txt as well. So now I will run my build command again, and I will overwrite my previous image, right? I will overwrite my previous image with the new image which I'm creating, or I can give a new name. I press enter, and it uses 1804 as a base image. Add sample.txt, so it copies sample.txt and then defines the default command as cat sample.txt. All right, now if I run my newly created container, I say docker run my docker image, press enter, and it will print the contents of this file. So this proves that the file was copied from my local machine to the image which I wanted to create. Does it make sense? Any questions? There is a question. Can you explain the difference between VM and Docker image? I would love to do that, but we are not here to understand the concepts of Docker. We are here to understand Dockerfile. So I will concentrate on Dockerfile for now. Sorry about that. So when you run a container like this, like I executed here, it does not run on background unless the default application runs as a daemon. Right now my default application is to print the content of a file. If my default application was like a Java application which runs in daemon mode, or some other application which runs in daemon mode, then it will continue Yeah, I understand the audio was lost. This happens to me many times. I don't know if it is um, what issue is this, because I'm using a different laptop and a network. Anyways, can you hear me now? Question is, can you run a web server using Dockerfile? Yes, we will do that as our example. Can we add file from SVN repository? You can add your file from SVN repository. Either you can download it or download in your image or download in your local file and then do an add. So let's maybe install an application, or maybe install what we can install an application in the image which is not present in the base image. So let me open the Docker file, and here I would say run a command called apt get install finger, right? Apt install finger. This may fail beforehand. I am suspicious that this may fail, but let's see. Yeah, something is wrong with the network here. So next time that happens, I will switch to a different network. Okay, so I will save this, right? So my Docker file, if I check again, my Docker file has run apt install finger. The run command, what run command does is, run command will execute a command to make some changes on your new image. Yeah. So I will say now Docker, let's build it. Yeah, so this failed. As I said, this is going to fail. So I'm going to change my Docker file, and I will say Docker apt update and apt install finger. So I'm going to update the command, update the apt cache, and update the finger application in my container or in my new image. Yeah, this should work, hopefully. So now I have finger installed in my container or in the image, right? So I have created an image based out of Ubuntu 18.04, and in the image I copied a sample.txt file, and also I installed another application, another utility called finger. Now how do we verify this? Let's again modify the Docker file, and now I will change the CMD to run finger command. Yeah, build an image again. Now I say Docker run my Docker image, and I get an output of the finger command. The finger command shows which users are logged in the current system, and it's not installed in my current system as well. So when I run it on the container, it says no one has logged in. Yeah. So is my audio breaking for everyone? Okay, for many people it is fine. Nikhil and Kirubakar, for you it's not fine. Huh? Okay, if I have missed someone's question, can you please Ask me the question back. Sorry if I have missed. Okay, now where were we? Okay, install finger, right? So one thing you noticed is no, to open the Docker file. Yes, one thing you notice is I have defined the cmd command twice. The cmd is nothing but defining a default command to be executed in the system, right? Now I did cmd bin cat sample.txt and also did cmd finger. What is the difference? Why did I use the cmd two times? So the answer is you can use cmd as many times as you want. Only the last cmd will be effective. The other cmds will be overwritten. Yeah, so whatever you define in the last cmd command or last cmd instruction will take effect. Okay, so there are some questions. One question is how to clean docker cache. What is docker cache? Can we please specify, because there is nothing called docker cache as of now. What is docker cache in your understanding? Question from Soumya: can we assign static IP for a container in Dockerfile? The Dockerfile is to create an image. An IP is assigned to a container. So when you run a container, at that time you can specify what IP should the container get, not in an image, because image can be used by anyone in the world. My query is add through, can we copy RPM in containers? Yes, you can use add command to copy RPM into containers and then install them as well. Is it necessary that the commands have to be run within Dockerfile? Can we write it as a list of commands in the shell? So you can, there is a way where you can write commands, create new container, commit new container, write command, create new container, commit new container. But that is not something which you want to do, because first of all, um, there is no need to do that because you can write everything in a Docker file. Second is you cannot share those commands with others. They cannot reproduce your images because you are writing commands manually on the system and not using a scripting way. And third is it is not useful for automating. It is always useful if you use an existing script or existing a file which stores all your data. That is why we prefer Dockerfile. Can we know best practices in Dockerfile? Well, first we should know basics of Dockerfile, right? That's what we are doing. How to increase the Docker container size? Again, what do you mean by size? The Ubuntu 18.04 seems cached in your system. It does not seem downloading anymore. Looks like reused from system cache. Yes, so once an image is downloaded on your system, then there is no need to re-download it again. Okay, this is not called cache. This is your image storage. Your image is stored locally. If you want, you can delete that image using docker rmi command and then download it again. Can we remove older images once new image is created? Because Docker images consume a lot of space in disk. So I am just recreating images so that older images are overwritten automatically, but you can delete them by using docker rmi command. Do we maintain versioning of for Dockerfile or Docker image? Yes, Dockerfile should always be versioned. Docker image should not be versioned because you can always recreate them using Dockerfile. What will be the storage size of Docker image? The Docker image storage size will be according to how much data you put into it. Right, Sahil says container 500 MB after if we deploy our application then require the size. I don't understand the question, Sahil. What size is needed and why do you want to increase the size? I don't know about the size you're talking about. If you're talking about RAM utilization, again, container is a process. So you don't define hard disk size for a process. Process runs in memory. So you can define how much memory your process takes. That is definable. When you run a container, you can define that. In images, you don't define that. What and all the requirements to run Docker in local system, that I will not cover here because this webinar is mostly for Docker files. Just to give an idea, you need to install Docker on your local system. right? Last thing, it seems I am allowed to use CMD only once. Yes, Karthik, CMD command is allowed to use only once. So the last CMD will override all the previous CMD declarations. Okay. Now, this is one more question. What is the difference between CMD and entry point? So people who are interested, an entry point is similar to CMD, but you can pass arguments to it, right? So for example, I can say entry point slash pin slash echo, yeah, and enter, and then I build. I think I should modify my Docker file, but it's okay. So now if I say run, I did not get anything, right? If I say Docker run my image, hello there, I get, okay, I still get nothing. Um, let's say maybe I'm missing something here. Let's comment the CMD part. Okay, entry point. What entry point is, although I need for some reason I'm missing maybe a trivial part of defining that. In entry point, you can also define arguments. When you define entry points, you can define arguments. Okay, so that argument is passed to your entry point. I'll try one more thing. Yeah, so entry point, maybe we have that in the presentation. If that is there, then I will explain that as well. Yeah, so let's wait for some time for entry point. How to configure network for Docker so we can access web server. Unfortunately, out of scope for this discussion, but I will show you how you can access your application from your system where you are running the container. That I will show. Okay. So we saw CMD. Entry point is echo. Yeah. So I gave the correct example. So entry point is nothing but the default program that is used, uh, that is run by your application. Yeah. So not sure why it is not working here. Let me give it one more shot. Yes, still it's not working. Anyways, so maybe we'll come back to this. Yeah, but entry point is similar to CMD. The only thing is with CMD you can pass arguments. Yeah, you can pass arguments. Sorry, with entry point you can pass arguments, not with CMD. All right. Now environment. What is env? Env is nothing but environment variables. For example, on Windows you specify some environment variables. Similarly, on Linux you can specify some environment variables, right? So if you want to some environment variables to be set by default in your containers when the containers start, then you can set up them using env, right? Let's see that as well. I will Let's not use entry point for now. Let's say env. Environment I will set is key is equal to value, right? My environment variable is key and the value is the value of the variable. And then I will define cmd as echo hash key, right? So I'm going to print the value of key, or not hash, dollar, right? What is the value of key? So let's build. Right, so when the command runs, the cmd runs, it prints the value of key. So because we are setting up a environment variable called key and adding the value as value, so that value is printed here, right? Similarly, you can set up more environment variables, maybe your proxy variables or your java path or things like that. Everything can be defined here. So env is to set your environment variables. Whenever a container is run, the variables will be automatically set. Now let's talk about expose. So if our application runs in the backend and runs as a daemon, right? So that means our container runs and it does not, so application runs continuously and we want to access the application. It has to be accessed on a certain port, right? We can define ports which should be available for external world. So external machines or your Docker host itself, where the application should be available, which is running inside a container, right? So that is defined using expose, right? So that means if we say expose port 8080, then if you try to connect to a container on port 8080, you will see your application. We will see that in a moment. Right now I will skip the demo for this because we will see that in detail in coming months, coming time. From, we have already seen, from is like from which basic images you want to create your Docker file. You can choose only one image. Maintainer is a command which you can use to give name of the person who is maintaining this image. You can give your name or your company's name, whatever you want. Run, as we saw, Can you hear me, guys? Am I audible? Okay, thank you. Finally, I'm connected back. Okay, sorry, there was a mess up in the connection again. Let me come back and see there were some questions. Question is run difference between copy and add. Uh, Using add command, you can also download or copy files from a URL. With copy command, you can only copy local files. With add commands, you can copy files from URL as well. And also you can auto expand zip or tar archives. Um, Run and exec are almost same, but not getting into too much details. Docker Compose is a way to run your multiple containers together as a with a single command. Yeah. Okay. All right. Let's get back to the discussion. So I will become sudo again. Yes. Okay. So what did we see? We saw that key value was done. Yeah. So environment variables are also set. So let's check what is a work dir. Work dir is what is the current working directory you want to set in your container when a container executes, right? We can maybe do this, although I don't see a point, but we can change the Docker file and say work dir is slash etc. Yeah, and then I will say run default command as pwd. So it will show us what is the default command, that is what is the current directory when the container starts. So by default container, the default directory will be root, but I say that our default directory should be etc. So I save it, build, and run docker run, and it says that current directory is slash etc because we set it up using work dir command. Okay, makes sense. All right, question is what is Docker Swarm? Docker Swarm is a container orchestration uh, platform given by Docker where you can create Docker clusters and host your application, Docker application on those clusters, right? Okay, now let's quickly get into our example. So for example, here we will try to create an image which will serve HTTP, right? Which will serve our, which will be an HTTP server. Yeah. So how are we going to do this? We are going to use an Ubuntu image. This is an old example based on 12.04. I will use 18.04 image. Maintainer we will set to Edureka. We will install Apache 2, which is our HTTP server, right? And then create some environment variables and start our application. Yeah. So I have already copied this in my notepad, and I will take this and create as my Docker file. We will talk about this in detail now. Nano Dockerfile -httpd. I'll remove one capital O. So I create this Docker file and I will paste it. Unfortunately, yeah, pasted it. So from Ubuntu 18.04, maintainer should be Edureka. Run command these. So this is, I want to update the apt cache in the image, then install Apache 2, and then clean everything, and then remove this temporary directory. Yeah, and then set some environment variables. One is Apache run user, Apache run group, Apache log dir, and then expose the port. Yeah, so that means we want to expose our application on port 80. So when Apache runs, it will be exposed on port 80. And here you can see we are defining a CMD. CMD is the default command when the container will run when it starts from the image. So it will be Apache 2, which is nothing but our HTTPD server, and in the daemon mode in foreground. Right? So this is Apache 2-D foreground. Yeah, I will save this and I will say build, Docker build. The file should be Dockerfile-HTTPD, and here I would say image name to be my HTTPD image, or instead of giving image I will say my HTTPD. And now it will take its own time to perform all the changes. There's a question coming in, question from Ani. You had told us that args can be passed with CMD. How are we passing -d in background? Okay, maybe I did not explain it correctly. Arg can be passed when you run an image or when you run a container. Okay, so when you start a container, you will just say now with this my HTTPD image created, we will say Docker run my HTTPD, and whatever is defined in CMD will be executed. We cannot say Docker run HTTPD and an argument, right? But with entry point, we can say Docker run HTTPD and then give an argument also. So while running a container, we can give an argument. For some reason, this is stuck. I will start this again. So now it is installing. And our application is installed. Yeah, I will say Docker run my HTTPD. Press enter. Says config variable Apache run dir is not defined. Let's see. Apache run dir is not defined. Huh? Okay, we will define that then. Let's set it up. Nah, not this one. env Apache underscore run dir. Let's say /var/apache2/httpd. Yeah, let's save this. Create an image again. Done. Let's run it. Default runtime must be a directory. Okay, that means I need to create a directory also. So here I will have to say run make dir var apache2 httpd. Need to redefine my command here. So see, we are exploring and enhancing our Dockerfile. If you write everything by hand, run all these commands by hand, which you can do, it does not add much value. Then you have to again do trial and error again and again. Why am I building again? All right, so now server will start. Okay, let's stop this server as of now because we want to access it. So I will run it with a special command. I will also run it with a docker run, then -p. -p is directly we cannot from external world, we cannot access the application on default expose ports. Okay, so we need to forward the port to the host port number. So I will say docker run -p 8080 my httpd. So what I'm saying is any application running on port 80 on this container should be available on port 8080 on my machine, and I run this command. So now HTTP is running. If I access my application on port 8080, I should get some data, hopefully, if I have started correctly. And we see this. Now I get my Apache 2, right? So I created my own image. Right? And maybe I can customize this. I can write my own index.html and put this here. So let's do that as well. Where is it? Yes. So I will stop the container and I will also create index.html and I will write h1 hello from Edureka, right? H1. So I'm customizing my image now. What I'm going to do is I'm going to copy. So instead of using add command, I can also use copy. And my source will be index.html and my target should be var www index html index.html. Yeah, and save it. Build. So I have made some change in my image. I have put my own custom index.html file, right? I will kill the existing container. Okay, there is no run container, and I will now run it, run the new container, run the new image which I created. And again, it should be available on port 8080, as I mentioned. If I refresh the page, I should get hello from Edureka, right? Now I can go ahead and give this image to anyone, my HTTPD image to anyone, and when they run container, they will always see hello from Edureka. Yeah, so this is how we can create our own custom images. Make sense? Any questions? Now, you talked about the other parameters which I passed while running a container. When I run a Jenkins container, right? I can do the same thing here. If I don't want anything to be printed here on the foreground, I want to run the container in the background, I can just say -d. -d will run the container in daemon mode, detached mode. So now my container is now running in background. I can still get the application here. Yeah. So yeah, this is how you can create your images, right? So this was something which I wanted to demonstrate. And that brings us to, is this enough for you? So this is not actually enough for you. Everyone should be able to So everyone should be able to understand the complete concepts of Docker and um, a concept of other technologies around the DevOps part, right? When you talk about DevOps as a skill set, you need to understand a lot of things apart from Docker, right? So we in Edureka have analyzed, what are the different requirements from various companies in their job descriptions, and we have identified, like for example, here there is a JD from Honeywell, from Headspace, and we have identified that teams or the users or the DevOps practitioners or experts needs these competencies: Linux fundamentals, infrastructure as code, uh, little bit of cloud experience, then containers, communication, continuous integration, and other DevOps tools, right? So Edureka has developed a DevOps course which you can go through. Maybe I can show you quickly, which you can go through and identify, maybe this is the skill set, or this course builds up the skill set that you need for your skill development to be able to become a successful DevOps engineer. Yeah. So if you want to upskill yourself on DevOps side, I will suggest, highly recommend, take a look at this DevOps course. The course fees is this, but definitely Edureka is going to extend some sort of discount for you guys, for webinar users. And all live classes, you can watch videos, you have complete access to all the learning materials for your lifetime. We cover, starting from DevOps basics, we cover version control, which is Git, then Jenkins, Selenium, Docker, uh, Docker Swarm, Kubernetes, Puppet, Ansible, Nagios, and also small introduction to DevOps on cloud. And that will really bringing the value that you may add to your organization or to your role by understanding all these concepts. Yeah. If you would like to know more about, and also get more details or get more discounts of these on this course, you can please fill up this form which I am sharing with everyone. I hope this works. Yes, so I'm sharing this link with everyone. Please take a look, and if it makes any sense, then subscribe to this course. I am also one of the trainer who gives this training, so you know I can say that this is very 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 helpful. Yeah. So yeah, thank you for attending today. There is a question from Sahil. Sahil says, environment is like variable value, just name changed key value. Environment is like setting up environment variable. Each variable has a variable name and a value, right? So you can say an env key is equal to value. Yeah. Question from Ani. Can you install Python on container and use it by running the container? Yes, you can do that as well. Yeah. How to kill, stop a running container? You can say docker stop and container name. Can you share Docker monitoring tool, any popular tool? So there are many Docker monitoring tools, like Prometheus is the most prominent. There are multiple others. You can have your own, data analysis tools and all, but Prometheus is the most important or most famous tools, I would say, right now. Can we get recording? Yeah, Edureka will share the recordings of this webinar with you pretty soon. I guess they will take some time to process the recording, but they will share it with you. Yeah. So that is all from my end. I hope you had a productive 1 hour 47 minutes with me, or 1 hour 27 minutes with me, and I wish you all the best in your career. I hope you are able to learn as much as possible and be successful in your career aspirations. Thank you, Sani, for joining today, and have a good day. Bye bye.